Hello guys, and welcome back to another tutorial. On this second tutorial I would like to go through how you calibrate the device cameras essentially, or the device sensors, where I will basically go through the guide I wrote. So if you go to the SMapper documentation webpage, if you go to guides, you will see this calibration guide here, and basically the way this works is we are using the Calibration toolbox to obtain all the results we need, where we will go through the intrinsics and extrinsic calibration, so camera IMU calibration, and also we require, or the Calibra requires, the IMU noise model, where we use the Allen variance method. For you to calibrate the device, you will need a calibration target. The recommended one is this April grid, which is a 6x6, 80 centimeter by 80 centimeter April tag, which is an A0 page. You can find the PDF to download on the Calibra wiki. It is best to, of course, mount this on a rigid panel, which is matte, with the matte finish, because from when I did mine, because of mine had a bit of a reflection, sometimes it could make the calibration worse, but it is what it is. In terms of the calibration process, it's not very hard. We need two types of data sets, okay? The first one is IMU data. And the way this works is you put the device in a static place and ensure that it will not be moved at all. And you just record the IMU data, that's all. Ideally, you want minimum of 3 hours data, but I went for 20 hours. So the more you have, the better it will be. Once you have this, and you do this for both the Auster IMU and the RealSense IMU, or any other IMU you have. Once you have this data, then you can go and collect the data for the cameras. So the way this works is you take a ROS bag where you have a camera, a source, or a camera frames, for example the front right camera, and you have also an associated IMU or more. So I have used the Auster IMU, and the way you do it, the recording itself is not very hard. You just make sure you are always pointing the device or the camera to the target, and you must exert all the axes of the IMU, so you can go up and down, and then forward, backwards, right, left, and then you need to do also the rotation axis, so for example pitch, roll, and then yaw. And roughly this is about 1 minute, so just you can do it twice, twice up and down, back and forth, and so on. But yeah, roughly it's about 1 minute. You can also collect a stereo camera setup. So you can put the two front cameras, for example, and you just need to make sure, of course, the both cameras can see some part of the same, some part which is the same. So once you have all this data, what you need to do is put all these ROS bags into a folder, which has the ROS2 folder inside, and inside you put all your bags. And this is very important because our tool, the SMapper toolbox, requires this format, okay? And so once you have this, all you need to do is to use the SMapper toolbox. Now, the way you can use this is by cloning the SMapper, which is actually quite important to clone, and the toolbox will be available inside the software SMapper toolbox as a sub module. So now I will go through a bit what we'll do. So here I have my let's say my ROSbag directory, which has a ROS2 folder. You can ignore these two. And inside this I have 3 types. So I have 2 cameras and the Auster calibration, which is a 20-hour dataset, which is about 3 gigabytes, not a lot. And now I'm here in the SMapper toolbox, which you can see is in SMapper software and then SMapper toolbox. So the first thing you want to do is you will want to open the configuration file inside this config folder, and you will need to make some changes. So you need to change this base dir. So base dir is where the SMapper repository is, okay? So mine is in work SMapper. The calibration dir is where you will have your targets, okay? SMapper has this calibration already, so you can use it as well. So SMapper calibration caliber, and the results will also be saved here. And then you have the ROS2 dir, which in my case is in this path, and you put the root path, not where the ROS bags are. Okay, then the rest, you don't really need to change anything. So this should stay the same. This you can increase or decrease the number of parallelizations. And this is where you can like change where it will save the results. So right now it's dynamic, intrinsics, extrinsics, and then static for the IMU. So once you have this, so the main things you want to change is this. You will need UV toolbox, okay? You need the, where is it? Here, the UV Python package manager. And once you have that, you can do UV run toolbox. And then if you do help, you will see that we have 3 commands or possible commands. And the first we want to do is the caliber. And then if you do help, you will see that we have cams, IMU, cam IMU, and all. Okay, I will do all. So you can run these separate, okay? So cams will calibrate the intrinsics, IMU will obtain the IMU noise model, and cam IMU the extrinsics essentially. So if I do all and do help, you will see that we have also options to put. So you can change actually here where the ROS-BAG's path is here as well. So it's up to you where you want to change. So once we hit this, this will run, and the first thing it will do is it will look through the bags, and if they have not been converted yet, they will be converted now. So we have about 3 bags to be converted, and they are being converted the 4 or the 3 at the same time, because we can parallelize 4 times, right? That was in the settings. So right now we have already 2 done. And so once this has finished, it will proceed with the actual calibration. Okay, just a bit more. This should be the ulcer, which is a bit bigger. So you can see here it has found the 3 bags that I had it there on the folder, and it is actually putting it on this ROS1. So now you can see there's a ROS1 with the bags here now. So it's almost done. There we go. So then it will try and verify if the contents are correct, if there is the Docker image. If there is no Docker image available, it will build it first. And then it does some analysis on the ROS-BAG, so it can be faster to see what topics there is, and it will compute their frequency and so on. And this will be cached, so if you do this on another time and have the same bag, it will be faster. Although this was quite fast because it's using the ROS2 metadata. So right now it's running the intrinsics calibration, okay? And since we have 2 bags which has, you see here, camera image ROM, and then another one which is the ulcer IMU, this is valid because it has the image, okay? So this will take a little bit of time. All right, it finished. It was about 2 minutes. Now it's going through the Allen variants. So if actually we take a look where it is saving, if we go to SMapper, calibration, caliber, dynamic, and intrinsics, sorry. So actually this is from yesterday. I did it was these 2, no? Yeah. So you can see it has updated. So I can remove these and this. So these are the results from the camera intrinsics calibration, and it gives you a small report here which you can look through and see how good they are. And now it's running the Allen variants. So this should go to static and IMU, and then it should go through this one. Okay, already has it. So this is the configuration file. If I open this in LibreOffice, so it detected that it has a rate of 100 Hertz and the total time and the topic. So this is required by the Allen variants, that's why it's here. In the meantime, let me put make this default. Okay. So you can see that this is a plot it gives. I don't know, that one was, I think, the white, no, the gyro, maybe. Not too sure which one was. No, it was the accelerometer. So this is the gyro. These are saved, okay? So if I go back here, calibration, caliber, static, IMU, this one. So you can see now the plots are here. Ah, yes, this is because I have other bags. Don't worry about this. But actually, I mean, what he's saying here is that he doesn't find the calibration file. Which is this camera wheel sense, which is true. I don't have this one, so it doesn't consider this IMU noise configuration. But yeah, so this will take again a bit of time, and once this finishes, I will be back. All right, it has just finished. Took about 5 minutes, and now if we go and look back at the results, again, it should be dynamic and then extrinsics. Here we have the two things, the results. So yeah, we can see here all the possible results we got. And yeah, that's basically it in terms of calibration. Now you need to do some extra steps in terms of having it ready to be used for the device. If you go to SMapper repository and you go to software, so SMapper toolbox and SMapper toolbox again, a configuration, you will see here this transform input example YAML. And this is the only manual step you kind of need to do in a way. And this is to generate the entire tree, okay? Which can be seen, I don't have it here with me, but basically we have the baselink frame to OS sensor frame. This one is based on the CAD model, okay? And then these are values from the datasheet of the LiDAR. Same, these are from the CAD as well. But what is most important here right now, and it's the one work, are the cameras to IMU, okay, OS IMU in this case. So all you need to do is you go to the results, for example, this front left calibration YAML, and you see this T cam IMU, so transformation between camera and IMU. You just copy this, and we literally just paste it here, and you do that for all the 4 cameras. Right now the RealSense is not really working. Actually, it is here as well, but I'm not using it for now. So once you have that file filled in, okay, all you need to do will be to run again the toolbox, and then it will be TF transform generate, and then input you put this file, and output you can put any name you want. So once you run this, it gives you a bit of the tree structure here, and you will be having this launch file as well as the TF output. So if you look at the output, it's just the TF like ROS way of displaying it, kind of. And you also have the launch file, which is ready to be used. So essentially what you need to do is then copy this file into the SMapper device, and in specific you should put it in the SMapper bring up launch file, and you put it here. Okay, so the other step is you also need the camera informations, and this is also going to bring up configurations and calib, which is here. But if we look into the the results here, let's see, let's go pick up a fast here. So you will see that we have the distortion, but this is not compatible with ROS. Okay, so what can we do? Well, we can run again the UV run toolbox cam info, generate, and then you put the input, so the file you want. In this case it's the front left, cam chain, IMU, or just the intrinsics, it doesn't really matter, the one that has the parameters. You write output and the output file you want, and very important is this camera name. So here it's camera left, for example. So you run that, and this will then generate the camera info file, which now this is compatible with ROS. Okay, so what you do is just copy this again, and you just put it here, front left. Okay, and that's it. So once you have that, your calibration should be successful, and it should be good to go. But yeah, just you can just read this documentation as well. I think it's easy to understand. So thank you for watching, and I will be back with another tutorial, maybe not. See you.